to each other.
I hear that. Okay, so this one, we did a whole bunch yesterday. I'm talking over you, shush. We did a whole bunch yesterday with the calculator. So today, we're going to practice some free response without the calculator. So, a particle moves along the x-axis, and it gives you the velocity. It gives you that equation. So, find the acceleration. How do you find acceleration from velocity? Yes, the derivative. So, the acceleration is equal to the derivative of velocity.
Do I have to spell these words out on the test? But if I write,
they do not count off for spelling as long as they figure out what you're saying.
Okay. That might all be over.
So, the derivative of -1 goes away. The derivative of e to the whatever is e to the whatever. And then we also have the derivative of 1 minus t, so that's -1. So really this is plus. So it's e to the 1 minus t. You all good with that?
Yeah.
Say that again?
That's a T.
This, yeah, that E. Oh no, that's a plus sign. I just changed that negative to a plus. Okay, so then we find the acceleration at 3. So that's e to the 1 minus 3. That's e to the -2. We can't have a negative exponent. So it's 1 over e squared. And we would leave it like that, because this is a non-calculator problem. Did you have a question? Oh. We good? All right, B. Is the speed of the particle increasing? Give a reason. How do you figure out if speed is increasing?
Velocity and acceleration.
Yes. Velocity and acceleration, in order for it to be increasing, have to be same sign. If they're opposite signs, then it's decreasing. Yes. So we have the acceleration, 1 over e squared, that's positive. E is 2.718, blah, 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 blah. And you square it, it's still going to be positive.
So it'll be 4 point.
There you go. Probably end up being 5 point something, but whatever. It doesn't matter, it's going to be positive. Now for velocity, so v of 3, that would be -1 minus e to the 1 minus 3. So it's -1 minus e to the -2. -1. Yeah, minus e, 1 over e squared. Yeah. A negative and then minus something. That's also 2 negatives. Yeah, it's going to be negative. So this is less than 0. So the speed of the particle is decreasing. I put not increasing because the question was, is it increasing? But that would have been fine. Decreasing because a of 3 is less than 0 and v of, I said that backwards, just kidding, is greater than 0 and v of 3 is less than 0. Y'all feel good about that? Whoop, whoop. All right, C. Find the values of t at which the particle changes directions. Direction. Velocity. We set the velocity equal to what? 0. And we find critical values and that's going to tell us when it changes. So velocity is -1 minus e to the 1 minus t equals 0. So add 1 to both sides. Divide by -1. That's not possible.
Q.
Yeah, e to a power is always going to be positive. Because e is an exponential function, it looks like that. So since this is not possible, then there is no change in direction. And then D says the function, it's a little bit different, models the position of the particle for t is greater than or equal to 0. Find the total distance that the particle traveled on the time interval from 0 to 3. So, total distance. Well, if it never changes directions, then it's the same as what? Net distance. Which you would just take absolute value of p of 3 minus p of 0. Plugging in 3 into that equation, e to the, minus 3, and then minus p of 0, e to the 1, so e. So e to the -2 minus 3 minus e. Yep. That's all we can do with that. This is a non-calculator problem.
Is that a slide on the boat?
Yes.
Okay.
Yeah.
Alright.
I should do
I enjoyed it.
that.
All right, next. Still no calculator, but this time instead of having an equation, they gave us a picture. Okay, so a car is traveling on a straight road, and it's from 0 to 24 seconds. The velocity is in meters per second, is modeled by this picture. So this is velocity. All right, A. For what interval or intervals of time does the car have 0 acceleration? Show the work, explain the analysis that leads to your answer.
4 to 16.
Yes. I agree.
I agree as well. So we would say 4 to 16 is the interval.
And
Why?
it's open.
The slope of
Yes, it's open. It's not going to include the endpoints because at the endpoints it makes a change there.
Okay.
the slope
But-
of v is 0.
The slope of
V.
V is 0. Yes, absolutely right. So it's constant. Yes. But say you put closed interval, unless it is something they're specifically looking for, like if it's saying doesn't include endpoints, blah, 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 they don't make a distinction between open and closed intervals.
Because I might just make a really confusing parenthesis and make it look like open. And then they'll be like,
No, they would just count it wrong. But no, they usually don't care.
yeah. They'll be like, can you?
They usually don't care. Okay, so 4 to 16, it is because, let's say, is when the acceleration, isn't that what I had asked for? Yeah.
Mhm.
Acceleration equals 0 because the slope of v of t is 0. Or you could say the graph of v of t is constant at that point, or it's linear at that point. Well, they're all linear. It's a horizontal line at that point. There's lots of different ways you could answer that question. Are you comfy, Daniel?
What?
Are you comfy?
Yeah.
Good. I'm glad.
I stretch my legs.
Keep me in a circle this
That bothers me.
All right.
time. I'm looking
Why
at
would
it.
I say such thing?
V, for each value of v prime of